Hello, dear students. Once again, I welcome you all to KLS Gokte PU College of Commerce and Science, Belgavi. This is our lecture number 7 on topic surface chemistry. And myself, Mr. Akash Vasan Nesarkar, lecturer in chemistry, Department of Chemistry. Now, let us discuss the contents of today's class. In today's class, we will be dealing with the purification of colloids, properties of colloids, and some applications of colloids, and also what is meant by coagulating value and the flocculation value. So these all 4 points we are going to discuss in today's class. And I request you student to focus on these 4 points because it is very important for the final examination. So I request you all to pay the attention. Let us discuss the purification of colloids. So the purification of colloids can be done by 4 ways. The first one, that is a dialysis, second one electrodialysis, and the third one ultrafiltration, and the fourth one ultracentrifugation. The first three, that is dialysis, electrodialysis, and ultrafiltration, are there in your syllabus. And ultracentrifugation is just for the sake of knowledge, we will study that. Now let us try to study one by one. The first one, dialysis. You might have heard this word dialysis, right? Okay. So what is a dialysis? See, this dialysis process is based on the principle that impurities of true solution can pass through the parchment paper, or you can say that is a filter paper. But the colloidal particles cannot pass through the parchment filter paper, okay, or parchment membrane, or you can say animal membrane. So if we take the impure colloidal solution, the impure colloidal solution will have the colloidal particle as well as the impure particles. If the impure particles are very small than that of a colloidal particles, then we have to run the dialysis process by using the animal membrane or parchment paper. So the dialysis process is very simple. That is nothing but process of removing of crystalloids to the required extent from colloids using a suitable membrane is called dialysis. सो इसमें जो भी इम्प्योर पार्टिकल है उसको हमको निकालना है थ्रू द कोलाइडल सॉल्यूशन. कोलाइडल सॉल्यूशन में से हमको इम्प्योर पार्टिकल निकालना है. कैसे? बाय सस्पेंडिंग द इम्प्योर कोलाइडल सॉल्यूशन in a continuously flow of a water. So the apparatus used in this method is called dialyzer. So this apparatus, entire apparatus is called dialyzer. It consisting of a bag. So this is a bag made up of parchment or cellophane. So it is made up of parchment membrane. The bag is filled with the impure soil. The bag is filled with the impure soil. So in this impure soil we are having the crystalloids, that is impure particles, and also we are having the soil particles, that is the colloidal particles. Okay, so we have to remove the impure particles. And the bag is suspended in a tank through which pure water is circulated. Pure water is circulated. So in this bag we are having the impure colloidal solution. The water is continuously flowing through inlet and the outlet, okay, and this impure colloidal solution is having the crystalloid as well as the colloidal particles. So we have to remove the crystalloid because those are the impurities present in the colloidal solution. So we know that the crystalloids are having the smaller particles. Crystalloids are having what? Smaller particle, and these particles can pass through the filter paper easily, and therefore we are using the animal membrane or parchment membrane where we can pass the crystalloid particles easily, but we cannot pass the solid particle easily, and therefore with the flow of this water the crystalloids can be easily separated from the impure colloidal solution, and the colloidal particles will remain in this bag. So this is the best way to remove the crystalloids from the colloidal solution. So this process is called as a dialysis. This process is called as a dialysis. So in this process, dissolved substances are removed from the colloidal solution by means of diffusion through the suitable membrane. So I hope you understood this. Okay. So this process is called dialysis. But this process takes more time or a longer time, or you can say it is a longer process, and therefore in order to make this process faster, we have the another process of purification, that is electrodialysis. Suppose in impure colloidal solution, if the impurity are electrolytes, if the impurities are electrolyte, then we can remove those electrolyte by suspending the electrodes, by suspending or electrodes. So we know that we are having the positive electrode, that is anode, and the negative electrode, that is cathode. If our impurity is electrolyte, then we can remove those impurity by suspending the electrodes, that is cathode and anode, and we can make the process even faster compared to dialysis. As we know that the dialysis is quite slow, but we can make it faster by using the electrodes, and therefore this process is called as a electrodialysis. And remaining further things will remain as it is. So further things will remain as it is. We are having the impure colloidal solution, and also in that we are having the impure electrolytes, and we can remove those electrolytes by using the electrodes, that is cathode and anode. So electrodialysis, the process of dialysis is quite slow. So if the dissolved substances in the impure colloidal solution is only the electrolyte, then electric field is applied. The colloidal solution is placed in a bag of suitable membrane while pure water is taken outside. So by using these two electrodes, we can remove the electrolyte impurity from the colloidal solution, and the entire process is called as a electrodialysis, because we are using here cathode and anode as a electrolyte or by using electricity, and therefore it is called as a electrodialysis. And this process is very fast compared to earlier process, that is dialysis. Okay, fine. The next one, ultrafiltration. So in ultrafiltration, we know that the ordinary filter paper has the larger pores, means pores are nothing but holes. तो फिल्टर पेपर पे क्या रहते हैं, होल्स रहते हैं. सो ऑर्डिनरी फिल्टर पेपर्स पे ज़्यादा साइज के होल्स रहते हैं. देयरफॉर वी कैन नॉट यूज दोज फिल्टर पेपर फॉर द प्यूरिफिकेशन. Therefore, we cannot use those filter paper for purification. Why? Because if we use the ordinary filter paper, the impurities also pass through the filter paper, and as well as the colloidal particles also pass through the filter paper. So that there is no sense to use the ordinary filter paper, because your impure colloidal solution will remain as a impure only if you use the ordinary filter paper. But instead of ordinary filter paper, if we use the ultra filter paper, whose pore size are very small, and through those pore size only we can pass through the smaller impure particle, not the colloidal particle. Okay, if we use the ultra filter paper, then only the crystalloids, that is nothing but impure particles, can pass through the ultra filter paper, but the colloidal particles which are bigger in size, those cannot be passed through the ultra filter paper, and therefore this process is called as a ultrafiltration. Is the process of separation of colloidal particle from the solvent and the soluble present in the colloidal solution, especially prepared filters called ultrafilters. So we are using here ultrafilter paper. So you can see here in the diagram, these small things are nothing but what, crystalloids or impure particle, and these bigger size are nothing but what, colloidal particles. So if we apply the pressure, this is your this dotted line indicates it is ultrafilter paper. So when you apply the pressure from one side, only the crystalloids are passing through this ultrafilter paper, but not the colloidal particles. So in one side you will get the pure colloidal particle solution, that is colloidal particle solution, and in another you are getting the impure colloidal particles. So this is the process which is called as a ultrafiltration, and this can be done by using the ultrafilter paper, which has the tendency to pass only impure particles but not the colloidal particle. Fine. So the process is called as a ultrafiltration. Next one, centrifugation or ultra-centrifugation. So student, this part is not there in your syllabus, but for the additional sake of knowledge, we are going to learn this. So centrifugation. First of all, centrifugation, a centrifuge means, centrifugation is nothing but what simple it is. Suppose if we are having the suspended solution, that is what precipitate solution, fluid containing suspended particle matter. Okay, now we have to separate this fluid containing suspended particles matter into two layers. The one layer should be a palette and another should be a supernatant. So how can you do this? See, if the test tube containing the suspended solution, then we have the rotor here, or you can say a centrifugation machine, where we can suspend these test tube and we can rotate this test tube for 1 or 2 minutes. After rotation, what will happen, the whatever the solid particles are there in this tube, those particles will settle at this bottom. You can see here, those particles can be settled at the bottom, and only the liquid portion will be above the layer of the solid. So this portion is called as a residue, this portion is called as a supernatant. So in this manner, we can easily separate the colloidal particles and the impurities by using the ultra centrifugation, or it is also called as a centrifugation. Simply we have to take the suspended solution and suspend that into a rotor. It will rotate the test tube in a such a way that you will get the two layers. First one is a pellet and second one is a supernatant. So in this manner we are going to separate the impure particles from the colloidal solution. So this is for your sake of knowledge, that is centrifugation. So no need to buy it for the final examination. Now next one, properties of colloids. So there are various properties, general properties and electrical properties and so on. So one by one we are going to deal today. So first one, general properties. So in general properties, why it will show the colligative properties, the colloidal solution? Because due to high average molecular mass of the colloidal particles, mole fraction of the dispersed phase is very low, so the values of the colligative property are very slow. So whatever we will get the value of colloidal particle, it will be a very small, because it will have the average molecular mass of the colloidal particle, and the mole fraction of the dispersed phase will be very low. That's why the colligative property are very, value of the colligative property is very small. Color property. The color of the colloidal solution depends on the wavelength of the light scattered by the dispersed particle. It means what? The colloidal particle will disperse the scatter the light, and due to the scattering of light, it should, the wavelength of the light further depends upon the size and the nature of the particle. So when the light scattered, we know that it will undergo the scattering of light will show the wavelength, and due to this wavelength it will show the color property. So the color of the colloidal particles also depends on the matter in which observer receive the light. So colloidal solution will show the color property due to the scattering of light, that you remember. Next one, visibility. Can you see the colloidal particles by our naked eyes? No. Yes, the particles of the colloidal solution are not visible to naked eyes or under ordinary microscope. So if we use ordinary microscope also, we cannot see the particles of the colloidal solution. And last one, filter ability. Colloidal particles can pass through the ordinary filter paper. Just we have discussed this. It can pass through the ordinary filter paper, but cannot pass through the parchment filter paper or animal membrane or ultra filter paper. So you remember this. Just we have discussed in the ultra centrifugation method, right? Sorry, ultrafiltration method. So colloidal particle can pass through the ordinary filter paper, but it cannot pass through the parchment paper or animal membrane or ultrafilter paper. So these are the general properties. It shows the color because of the scattering of light. Visibility, we cannot see the naked eyes or the ordinary microscope, and the filter ability, it cannot pass through the ultrafilter paper, animal parchment paper or animal membrane. Okay, but it can pass through the ordinary filter paper. So these are the general properties of the colloids. Next one, okay, optical and mechanical properties. So we are having these important properties, Tyndall effect, and first one is a Brownian moment. So Brownian moment and the Tyndall effect, these are the optical and mechanical properties of the colloidal solution. So Brownian moment, it is very important. See, the Brownian moment soul particles move in a random zigzag manner due to the unequal parts of the particles of dispersion medium on the particles of a colloidal solution. is called Brownian motion. So Brownian motion बहुत ही simple है. So you can also say like this, the zigzag movement of a colloidal particle. So this is what the zigzag movements of the colloidal particles in the colloidal solution is called Brownian movement. This motion was first observed by the British botanist, that is Robert Brown, and therefore it is called as a Brownian movement. This Brownian motion arises due to the uneven distribution of the collision between the colloidal particles and the solvent molecules. So a Brownian movement क्यों arise होता है? Because there is an unequal distribution of the collision. So collision will take place between the colloidal particles and the solvent particles of the colloidal solution. So whatever the colloidal particles and the solvent molecules are there, in between those the collision will take place, and that collision leads to the zigzag movement of the colloidal particle, and that zigzag movement of the colloidal particle is called as a Brownian movement. If the smaller the size of the particle, lesser the viscosity of the solution and faster is the motion. So you remember this point. Smaller the size of the particle and lesser the viscosity of the solution, faster is the motion. Next, the second is Tyndall effect. So Tyndall effect is due to the scattering of light by colloidal particle. When the colloidal solution is placed in a dark, and when a beam of light is passed through the solution, the path of the light becomes visible with a bluish light. This phenomena is called Tyndall effect. The scattering of light illuminates the path of the beam in the colloidal solution. So it's very simple. See, we are having three solutions. The first one is a true solution, second one is a colloidal solution, and third one is a suspension. When the beam of light is passed through the solution, all these three solutions, the colloidal solution will start to scatter the light, and therefore we see the path of the light. The path of the light, it is due to the scattering of light. Who will scatter this light? The particles which are present in the colloidal solution. But in case of solution, we are not going to see the path of the light. Therefore the path of the light in case of true solution, it is negligible, because very small particles are there and those particles cannot scatter the light. But in case of colloidal particle, it scatters the light, and this scattering of light by colloidal particle, this property is called Tyndall effect, and this property is an optical property. Remember, so Tyndall effect is nothing but what? The scattering of light of a colloidal particle which are present in a colloidal solution. Fine. Both is simple. It will show the path of the light in its own solution, that is a colloidal solution. So that is called as a Tyndall effect. Next one, properties of colloids, that is third property, electrical properties. See, the colloidal solution may have positive charge or it may have negative charge. Okay, the colloidal solution may have the positively charged particles or the negatively charged particle. But how to confirm those? How to confirm that whether it is having the positive charge or the negative charge? So that is a big question to us. But we can find out that by using the electrophoresis method. So charge on the, let us discuss this electrical properties. Charge on the colloidal particle always carry an electric charge. So charge on the colloidal particle always carry an electric charge. The nature of this charge is the same on all the particle in a given colloidal solution, and it may be either positive charge or the negative charge. So colloidal particles may have positive charge or it may have negative charge. The charge on the particle is due to either given reason, due to the preferential adsorption of positive or negative charge. So this charge is due to the adsorption of positive or negative ions, which is common and present in excess. If the positive ion present in excess, then the charge over the colloidal particle is positive. If the negative charge is present in the excess, then it is a negative. Fine. So we can find out the charge on the colloidal particle by using the electrophoresis method. So this is our electrophoresis method, where we are using the two electrodes, that is first one is the anode which is negatively charged, and the second one is the cathode which is positively charged, and both are connected to the battery. and in this U2 we are suspending the colloidal solution with the dispersion medium water. Initial the level of this colloidal solution is up to this. So level of the colloidal solution is up to this. But once we start the electricity, if the level rises towards the cathode, suppose this is our initial level, if the level rises to up to this, then it confirms that the colloidal particles are moving towards the cathode, and this cathode is what? Positively charged. If the colloidal particles are moving towards the cathode and the cathode is positively charged, it indicates the colloidal particles may be negatively charged. समझ में आ रहा है? अगर कोलाइडल पार्टिकल पॉजिटिव चार्ज कैथोड की तरफ मूव कर रहे हैं तो इसका मतलब कोलाइडल पार्टिकल पे क्या चार्ज है? नेगेटिव, बिकॉज पॉजिटिव अटैक्स नेगेटिव. रिमेंबर, अनलाइक अटैक्स ईच अदर and like repulse each other. So it is simple. If the colloidal particles are moving towards the cathode, then it means that the colliding particles are having negative charge over it. Okay, and this process is called as a electrophoresis. So electrophoresis is the phenomena of movement of colloidal particle towards the oppositely charged electrode under the influence of applied electric field is called electrophoresis. So बहुत ही सिंपल है electrophoresis. Okay, it's simple, that is movement of colloidal particles towards the oppositely charged electrodes under the influence of electricity. So if it moves towards the cathode, then the colloidal particles are negatively charged. If it moves towards the anode, then the colloidal particles are what? Positively charged. Very simple it is. Next one, coagulation. So coagulation is nothing but precipitation. Coagulation is nothing but what? Precipitation. The process of conversion of sol into suspension is called flocculation or coagulation. So when the colloidal solution gets converted into suspension is called flocculation or coagulation or precipitation. So you have to convert that colloidal solution, that is liquid, into semi-solid or solid, and that process is called as a coagulation or precipitation. Are you getting? सो कोलाइडल सोल्यूशन है, उस कोलाइडल सोल्यूशन को हमको सेमी सॉलिड और सॉलिड में कन्वर्ट करना है. उस प्रोसेस को ही क्या कहते हैं हम? सस्पेंशन, और इट इज़ आल्सो कॉल्ड एज अ कोएगुलेशन और प्रेसिपिटेशन. आर यू गेटिंग? सो द कन्वर्शन ऑफ सोल इनटू सस्पेंशन इज कॉल्ड फ्लक्चुलेशन और कोएगुलेशन और प्रेसिपिटेशन. नेक्स्ट वन, द एप्लीकेशन ऑफ कोलाइड्स. The colloid is used as a thickening agents in industrial product such as lubricants, lotion, toothpaste and coating. So we can use the colloids in a paste for coating or in an industrial product such as a lubricants or lotion. Second one, in the manufacture of paints and inks. So it is also used in the paints and inks. Colloids are useful. In a ballpoint pens, the ink used is gel, that is a liquid solid colloid. We have already learned in second or first class, right? So ink is used is a gel, and gel is a type of liquid solid colloid solution. Okay, I hope you remember. The third one, the suspended impurities contained in the natural water are removed by adding sulfates of aluminium and iron which coagulates them. So the suspended impurities can be also be removed by using the colloidal solution. And last one, most of the medicines are colloid. So हम medicines देखते हैं, those most of the medicines are colloidals. Colloidal gold and calcium are injected into the human body for the vitality of the muscles. So for the vitality of muscles, we use colloidal gold and the calcium. Argarol, that is a silver sol, is used as an eye lotion. Albumin, starch and dextrans are few other colloids used in a medicine. So there are number of colloids which are used in the medicine. So today's class I will stop here. The further that is the hardest squeeze rule and the coagulation value and also the emulsion we will study in our next class. Okay. So if you have any doubt, you can contact us.